Hi everybody. Let's just continue talking about truth functional logic, and what we're going to be doing this week for week 12 is going over various parts of chapter 13 and chapter 14. So we'll be combining our knowledge of the truth functions from week 10 and the technical language from week 11 for our assignments and our reading assignments and our exercises for chapters 13 and 14. So this video will go over some of the specific parts of 13 and 14 that I want you to focus on, and hopefully it'll help you get through some of that material. So once you've gone through the reading, you can go back to page 273 and you can refer to the chart right above exercises 13.1, and that should help you go over exercises 13.1 and 13.2. The chart itself addresses translation issues with some English sentences that present oddities when they're spoken out in English. So those oddities can, confuse us a little bit when we're trying to translate them. So this gives you a decent set of examples for how to treat hard cases or confusing cases of English in your translating practice. Okay? I'll go over a couple of examples here. One example from the chart is the conjunction sentence. It's not the case that both Anne and Bob will go. So what you have here is you have a conjunction, but you also have a negation. The negation is presented at the beginning of the English sentence, and it goes on to exist throughout the remainder of the compound sentence. So you have a negation, and then you have a conjunction. And the conjunction compound sentence is actually what is being negated. So let's look at the compound sentence by itself first. Anne and Bob will go. We know at this point that that would translate into A ampersand B. We put that sentences in parentheses, and then we would add the tilde on the outside of the parentheses at the beginning of the sentence. So we would translate this sentence tilde, parentheses, A, ampersand, B, in parentheses. So that tilde exists outside the parentheses and the conjunction exists inside the parentheses. All right. Similarly, let's look at another example with a negation existing on the outside of a disjunction and existing in a pervasive way or throughout the entire compound sentence. Neither Anne nor Bob will go. So in this sentence you have another case where, again, the negation exists throughout the entire compound sentence, which includes a disjunction. So ultimately the sentence is a negation, and it is negating a disjunction, all right? So we can go ahead and we can look at that disjunction by itself. Anne or Bob will go. We know we would translate that as A wedge B. The disjunction is negated. That's clear in English. The either turns into neither. The or turns into nor. This is a great example of how that not exists throughout the entire compound and is in fact negating the disjunction as a whole. So for that reason, when we translate this, the tilde exists on the outside of the parentheses, on the outside of the disjunction. Tilde, parentheses, A, wedge, B, in parentheses, okay? Again, tilde is outside of the parentheses, the disjunction is inside parentheses. Okay, let's compare that sentence with another sentence from this chart on page 273. Either Anne or Bob will not go. Now this is different. It is a little different, okay? You do not have a singular not at the beginning of the English statement existing throughout in such a way that you have a negated disjunction, like the example prior to this one. But you do have a negation. You have a negation of both disjuncts. So this is a little bit of a different example. Either Anne or Bob will not go. Again, it's not pervasive in the same way as the last example is, but you do have the negation of both disjuncts. So how would we translate this one? Translate this one as follows. Tilde A, wedge, tilde B. Both disjuncts are negated on their own. It's not a negated disjunction, it's two negated disjuncts being combined. Another way you can understand the difference between these two sentences. The sentence neither Anne nor Bob will go is ultimately a negation. On a fundamental level, it is a negation statement. The main operator is not, whereas the sentence either Anne or Bob will not go is not a negation. It's a disjunction on a fundamental level. The main operator is or. Both disjuncts in that disjunction are negated, but the main operator is or. The sentence is ultimately a disjunction. Okay, let's continue. Let's continue through the reading and talk a little bit about the laws of grouping and exercise 13.2. The laws of grouping and those exercises are talked about on 274 and 275. There's also another chart right above the exercises 13.2, and what that does is it just highlights some unique cases of English and how you would translate them into the TL and how you would practice the laws of grouping. The laws of grouping encourage you to focus on commas and other grammatical pauses when you are assessing English sentences for the sake of understanding where compounds exist inside larger compounds. So let's go over an example from that chart. Let's look at the sentence, either Anne or Ed is home, semicolon. However, Julie is not home. Okay, so what we have is we have a large compound sentence, and we have more than one compound existing inside the ultimate compound sentence, right? So translating this and where to use parentheses, this is going to be a challenge. First things first, let's talk about all the operators that exist in this sentence. You have an or. You have the term however, which you know to be a conjunction operator. You have not, which is the negation operator. So we're dealing with a disjunction, we're dealing with a conjunction, and we are also dealing with a negation. Of course, these don't exist equally. There is one that is the most fundamental, and we need to understand that one so as to translate the sentence accurately. The good thing is that we have a semicolon in this sentence, and that's going to help us understand what this sentence ultimately means, or what it's fundamentally trying to get across. Let's go ahead and translate everything that exists before the semicolon. Either Anne or Ed is home. That's a disjunction. We know to translate that A, wedge, E. Okay, now let's look at everything after the semicolon. However, Julie is not home. Now remember, the semicolon doesn't end the compound. It just separates a large compound, okay? So it pauses the compound sentence, and it gives you an opportunity to group different aspects of this sentence in general. If you look at however, Julie is not home, like I said, we know that however is a conjunction operator. So we know we're going to be working with an ampersand. Go ahead and write an ampersand down. And then let's look at what happens beyond the however. Julie is not home. You have negation. What is the negated sentence? What is the content being negated here? The content is Julie is home. That's the negated sentence. I think pretty obviously we could translate Julie is home into a J. And because it is negated, we'd want to put a tilde in front of that J. So, overall, we have translated this statement to be E, wedge A, ampersand, tilde J. Ultimately, the sentence is a conjunction. While translating, we want to be able to represent the grouping that the semicolon offered us, and we want to be able to accurately present the main operator. So the disjunction requires parentheses. And what this is going to do is it's going to separate the E from the not J in an appropriate way, because it's the ampersand that's separating the two conjuncts here. It's the ampersand that is ultimately the main operator, and the rest of the statement is forming around it. Okay, so make sure you check out that chart while you're doing exercises 13 in 13.2, the ones I assigned you. And if you have any more questions on the assignments from chapter 13 or the material from chapter 13, you can message me with those questions and I'll go over it for you, or with you. All right, let's move on to chapter 14. Chapter 14 is really where we're going to be combining truth tables and translating, right? So the content from week 10 and week 11 are really going to come together, and they're really going to come alive here in week 12. So let's go ahead and see where chapter 14, or see how chapter 14 presents truth tables to us, okay? Don't forget, if you want, you can go ahead and review that video from week 10 on compound sentences, embedded sentences, operators, truth functions. All of that is held within the truth tables that are being presented on in chapter 14, okay? Letting P and Q stand as variables, these tables are describing the truth functions and the rules for how we go about truth functional logic. So the first table you come across is a truth table for the conjunction function. And you remember the conjunction function says that both conjuncts must be true for the conjunction to be true. And in every other case, if you have a false conjunct, or if both are false, the conjunction itself is false, okay? You'll see the tables where P and Q stand as variables for conjunction, disjunction, negation, and the conditional functions. Now, we introduced the biconditional statement in week 11. And during week 12, we really didn't go over the biconditional function. So I thought that I would write an example of a truth table down for you guys on a whiteboard here. And it is the biconditional truth table, okay? So this is the biconditional function, and it's given to you in the form of a truth table, which is what you're going to be going over in chapter 14 for all of the truth functions, right? So like I said, let P and Q stand as variables, okay? We deal with the truth value of the antecedent, the truth value of the consequent, and then, of course, the truth value of the compound statement that we're seeking to understand, okay? In the case of the biconditional, when the truth values are the same between the consequent and the antecedent, you have a true overall statement. And when the truth values mismatch, like in these cases, the biconditional is false. So this is slightly different from the conditional statement. I'm sorry, from the conditional function. I'm going to want you guys to be able to distinguish the truth functions for all of these compound sentences from memory, right? So my advice would be to write down these truth tables and study them, use them on flashcards while you're going through the exercises in chapter 14 and beyond. Definitely put these to memory, okay? So this is just an example of a truth table for the biconditional. And yeah, feel free to go through all of those. You're going to want to use the truth tables as well as the little section in chapter 14, which it's a chart on 293 called the summary of the truth functions to complete exercises 14.1. The summary of the truth functions really just describes the truth tables in like 1 or 2 sentences, okay? So sort of how I just described the biconditional truth table, that's what the summary of the truth functions does for all of the truth tables. Okay, moving forward through chapter 14, let's talk about the replacement method. And I'm just going to clear up some space here on the whiteboard. Now, while we integrate the material from from week 10 and week 11, what we'll be doing is we will be assessing the truth value of variable content, okay, or compound sentences that I give you with assigned truth value, right? So the replacement method basically gives you a method for assessing the truth values of compound sentences alongside given information about the truth values of embedded sentences, all right? So consider it like a set of hypotheticals, the stuff that you guys would be able to do based on your studying of the content from week 10. So if I were to tell you, you have a conjunction statement and one of the conjuncts is false, is the conjunction true or false? The conjunction is false. You guys know that already. So we're going to be putting that into practice, but we're going to be using, instead of English sentences, we're going to be using sentences in the TL. And truthfully, there's a lot of benefit to that. We don't have to worry about accidentally interpreting the truth value of an embedded sentence according to our own experience of the world. We can just deal with given information and variables like A, B, C, and sentence operators and truth tables, right? So it's a really streamlined process, and it's the process of truth functional logic. So that's what we'll be doing that's what you'll be doing for the remainder of chapter 14. So let's go over the replacement method and how exactly we're going to be integrating weeks 10 and weeks 11 here, all right? Like I said, the replacement method itself gives you a way to assess the truth value of compound sentences alongside different truth values or given information about embedded sentences, okay? So let's work with the example that's given to you in your text, not A and B. And let's say that I tell you that A is true and B is also true, okay? So you've got this technical sentence, all right, given to you in the TL, and you have given truth values here to represent, or I'm sorry, which are represented by the variables A and B, okay? Now, let's say I ask you, what is the truth value of this compound statement? Is it true or is it false? The statement, not A and B. Is it true or is it false based on the given information? The replacement method suggests that you reduce these variables into their given truth values for the sake of like streamlining your assessment of the ultimate truth value of this statement based on your knowledge of the truth tables and the functions, okay? So the A is true and the B is also true. So what we would do is we would replace A with T to mean true, and we would replace B with T to mean true. Of course, we don't want to forget the tilde there, all right? Okay, so now we have true, not the case that's true, and true. We're still trying to find the ultimate truth value though. Let's go ahead and assess this negation, right? What do you remember from the negation function? Refer back to the negation truth table, and you will find that anytime you have a true negated sentence, the negation itself is false. So we can go ahead and we can replace this not true with a false, okay? And we'll bring down the ampersand, bring down the second conjunct here, and let's go ahead and assess the final product here, okay? What do you remember from the conjunction function? If you have one false conjunct, the conjunction must be false, okay? The conjunction is only true if both conjuncts are true, all right? So ultimately, this statement right here is false, based on our knowledge, of course, of the technical language and how to assess the operators, whether they be secondary operators or primary operators, main operators, and of course of our knowledge of the truth functions and the truth tables. This statement is false. Okay. you're going to be using the replacement method while you complete the exercises 14.2 and 14.3 is what I believe. Let me just go ahead and, yes, 14.2 and 14.3. That information is just a little bit bigger, it's a little bit more complicated, so I figured I would just go over one example with you and then let you guys go for the week. So let's look at this example here from 14.2, and this one is a good one to go over. Let's see. All right, so let's say we're dealing with A, we're dealing with B, and we're dealing with C. So these are all the variables that the sentences will be made from in 14.2. Okay? And A is true, B is false, okay, and C is true. All right? So let's go ahead and do number 8. A and B or C. Let's go ahead and do number 8. And our ultimate goal is to understand whether or not this statement is true or false based on our knowledge of the truth tables, our knowledge of how main operators work and what parentheses mean in the technical language, and based on our understanding of the given information here. Okay? Let's go ahead and figure out if this is true or false. Now, first things first, replacement method, right? A is true, put the and, get in parentheses. B is false and C is true. So we have true and false or true here, okay? Now, with respect to the disjunction, I just want to make this really clear. And I'll write this on the assignment so you'll know for sure. I would like you guys to assess all the disjunctions you deal with in 14.2 and 14.3 according to the inclusive disjunction function, okay? So if you remember, the inclusive disjunction says that the disjunction is true if at least one of the disjuncts is true or both is true, okay? That's the inclusive disjunction function, and that's how I want you to assess the truth value of any disjunction in 14.2 and 14.3. All right, so let's go ahead and let's do that disjunction. Okay, let's reduce this into its truth value because it's the second conjunct, right? As you see, the ampersand is the main operator. This true is the first conjunct. This disjunction is the second conjunct. So let's simplify it, break it down to its truth value, and then we can finish the conjunction according to the conjunction truth function, all right? So anytime you have a disjunction, and in this case, the inclusive disjunction, if you have one disjunct that is true and the other is false, your disjunction is true, okay? According to the inclusive disjunction truth table, if your first disjunct is false and your second is true, the disjunction as a whole is true, okay? So now we have true and true, which, according to the conjunction function, we all know at this point, is true. Ultimately, the answer to number 8, this question, is A and B or C true or false? The answer is true, and that's how you go through it. Now, will this take a little bit of practice for you guys? Absolutely. Everything in formal logic takes practice, you know that. So that's what these exercises are. Don't feel discouraged, and I hope you have a good time going through them. And if you have any questions about how to do these exercises or any questions about any particular problem, you can message me and I will get back to you very quickly. So, all right, that's all I have for you guys this week, and I hope you have a really great week 12.